today we learn here inverse of matrix. See the definition of inverse. Suppose A is your square matrix and B is your another square matrix of same order that of B. Means order of A and order of B are same. Both are the square matrix. If these are the two matrices such that A into B or B into A is equal to R, where I is your identity matrix of same order that of A and B. If this multiplication gives you identity matrix, then we can say that B is inverse of matrix A. So B is called inverse of A. Or vice versa, we can say that A is inverse of B. But leave it, for we consider here B. B is inverse of A and inverse of matrix A is denoted by A to the power minus 1. So in place of B we can write A inverse. Hence we get the definition A into A inverse or A inverse into A is equal to I. Then these two are inverse matrices of function. So this is the definition of inverse of matrix. Now after getting definitions, now see the uniqueness of inverse. What is means of uniqueness? If A is your matrix, then it has only one inverse matrix. So this is your uniqueness. Now see how it is possible. See the proof of uniqueness of inverse of matrix. Let us assume that a square matrix A has two inverse matrices B and C. Inverse of A has two values B and C. So by definition, as A is inverse of B, therefore B into A is equal to B into A is equal to R. First. Second, again C is inverse of A, therefore A into C, C into A is equal to R. This is your equation. A has two inverse. We are assuming here, suppose a square matrix A has two inverse matrices B and C. B is inverse of A, C is inverse of A. So as B inverse of A, by definition A into B, B into A equal to R. As C is inverse of A, therefore A into C or C into A equal to R. Now we consider here B. So B is also written as B into R. R is your identity matrix of same order that of B. Now put the value of I. Value of I can take this value or this value. So I am taking this value A into C. The value of I is A into C, which is equal to interchange the value B into A into C. This is your property of matrix. Now which is equal to, but B into A is equal to R into C, which is equal to C. And I is identity matrix. After multiplying any matrix by identity, we get the same matrix. So hence we get B is equal to C. So as we are taking different, but after solving we get both are same. Hence it is unique. Means A has only one inverse matrix. So this is uniqueness property of the inverse of matrix. Now see the example how to find the inverse of matrix. We are solving the example. Find inverse of matrix A 1, 2, 3, 4. Now here we are using elementary transformation to find the inverse of given matrix. Now given matrix is, so given here, given matrix is A and has value 1, 2, 3, 4. By definition of inverse, A into A inverse is equal to R. So this is the definition of inverse. Put the value of A. A has value 1, 2, 3, 4. A inverse as it is, and I is your identity, and we know that identity matrix is of same order that of A. So this is your identity matrix. Now, how the process follow to find the inverse? This is matrix A. We convert this matrix into identity matrix by using elementary transformation. That we already seen previously. What are the elementary transformations used in matrix? There are 3 elementary transformations used in matrix. First, we can interchange into rows. Second, we can multiply all elements of any row by scalar. And third, we can add any 2 rows or subtract any 2 rows simply or by multiplying scalar. Now these are the 3 operations used in elementary transformation. Now, so here we are using elementary transformation and converting this matrix into identity matrix. While converting identity into identity matrix, the operation means we used in this side, same operations must be used for other side. Now, to convert this is in identity. Now see this identity matrix. In identity matrix, first element must be 1. In this matrix also there is 1. So hence no need of changing this element. Now we convert the remaining element, this element into 0, this element into 1 and this element into 0. So use the operation which we already learned. So we want here 0 means we are changing second row. How we change a second row? Because we need here 0. So therefore we are multiply first row by 3 and then subtract it from second row. So we get here 0. We are multiplying 3. After multiplying 3 minus 3 we get 0. So this is the operations used for converting element 3 into 0. So therefore we get. Now remember this is A inverse which is as it is for. Now we are changing second row, so therefore first row is as it is, remains same. We are only changing second row. Now while changing second row, use this operation because we need a 0. So therefore R2 minus 3R1 after multiplying R1 by 3 subtract it from second row. So multiply by 3, so 3 subtract from second row, 3 minus 3 we get 0. Multiply by 3, 6, 4 minus 6 minus. Here also the same operation. First row as it is, second row. Multiply by 3, 3, 0 minus 3 minus 3. Multiply by 3, 0, 1 minus 0, 1. So this is the first operation. We get 1, 0. Now we want here 1 and we want here 0. So first we convert 2 into 0. We can interchange the steps. Follow one direction while converting into identity. But here we are converting minus 2 into 1. We are changing 2 into 0. Because it is simple, so R1 changes to R1 plus R2. If this operation is taking place, we get 0 in place of 2. So therefore we get here, we are changing R1, so second R2 row is as it is. Again same operation must be followed to the other side, minus 3, 1 as it is. Now add R1 and R2. After adding, we get again 1. After adding this, we get 0. After adding, we get here minus 2. And after adding this 2, we get 1. So this is your your second operation. Now, we get 1, 0, here 0, we need here 1. So therefore, the next step is R2 changes to. Now here we are not adding, here we are dividing R2 by minus 2, then we get 1 in place of minus. So use this operation for second row. So as we are changing second row, first row is as it is. Here is also first row minus 2, 1 as it is. We are dividing second row by minus 2. Divide second row by minus 2 is 0 and we get here plus 1. Divide here minus 2, we get 3 by 2 and here is minus 1 by 2. So hence we get identity matrix in left side. So I into identity into any matrix means same matrix. So therefore we get A inverse as 3 by 2 minus 1 by 2. So in this way we get the inverse of given matrix by using